So slices are references. I explained that in class. So even though you can grab a slice from array A and store it in B, well, B is not a new location in computer's memory. It is a reference to what was stored in A. So if you change the items in B like so, you are actually modifying the items in A because they point to the same location in computer memory. So here you started out with A being 0, 1, 2, 3, 4, right? You don't get to 5, and this is an array range. And then you grab the second and third items, which will be 1 and 2, and put it in B, assign it to B, but it's a pass by reference. And so when you grab the first item in B, which is the second, which is at the second index in A, so it's the third item in A, and then we set it to 7. And the third item in A is 2, right? It's 0, 1, 2, 3, 4, right? And so we're going to have 0, 1, 7, 4, 5, because A has changed, B has changed, they point to the same thing. So 0, 1, 2, 3 was what it was before. This is the third index. We set it to 7. And then other items remain the same. And here we're printing A, but we modified B. Well, A changed because B is a pointer to the same address in memory that A points to. Multi-dimensional arrays. So you are not restricted to vectors, right? You can have two-dimensional arrays like we have here. And how do you create it? You can initialize it by providing two lists separated with comma of the same size. So the first one here will be the first row, and this will be the second row. So we have 2 rows, 4 columns. You can specify the data type with the second argument. You can print A, that's exactly what you get. You can run it again, so you see that. And then you can grab the shape with A.shape. You can grab the size, which is the number of elements in it, with A.size. You can grab the number of dimensions, and it's going to be 2 dimensions, right? Because now you have rows and columns, 2 dimensions. If any of those had only one item, meaning say you have only one column, then you have, say, n number of rows and 1 column. It's 1 dimensional. You have you have n columns, you have n rows, 1 column, same deal. As long as any dimension has only 1 item, then it's 1 dimensional. But here, both dimensions have more than 1 item. So 4 items in the columns, 2 items in the rows. So it's a multi-dimensional, it's 2D. So ndim is to A.size is 8 because there are a total of 8 items in there. The shape is 2 rows, 4 columns. Number of rows always comes before the columns. You can print the item at A, row 1, column 3. So what's row 1? This is row 1. What's column 3? Indexing starts at 0. So 0, 1, 2, 3. So it's going to print out 3. And then you can grab that item there. So let's run this. So this is A. It's 0, 1, 2, 3, and so on. A, row 1. So this is not row 1, right? Because indexing starts at where? 0. So this is actually the second row. This row, second row, and the 4th item. Because it's 0, 1, 2, 3. So it returns 13 when you print it. Let's run it. It returns 13. And then A at 1, 3, which is 13, we're going to replace it by -1. So this becomes -1. And then we'll print it out. And everything else is fine. And this guy gets replaced by -1. It used to be 13. We specified to have it changed to -1. A range. Start at 1, stop at 26. So first item is 1, second item is 2, last item is what? 25. We stop 1 short of the last item. This is an array because we've used numpy array range, A range. We can reshape A so that it has 5 rows and the number of columns is determined. So there are how many items? There are 25 items, right? Starting from 1 to 25. So we can reshape it. There's only one way it's going to have 5 rows. It's by having 5 columns, because 5 times 5 is 25, which is the total number of items. That's precisely what you have here. So 1 through 25 and shaped 5 by 5.